Hello everybody, welcome for tutorial 7 on our days of extremes and variability. And we're now going to talk about scenario dependency of future changes in extremes. So we're going to look at model data, which is new because so far we have only been looking at observational records, so a time series, and now we're also taking a little bit of a spatial approach in here, which is very cool. The objective is thus really to use the techniques we've learned so far to study extremes, and apply it to these different scenarios, these different SSP and RCP scenarios that you've seen before. As you know, by now, we cannot really assume stationarity anymore, given that the climate is changing, and these scenarios are a perfect example of that. So these are inputs from modelers that have different levels of fossil fuel emissions associated with them. Before we have the RCP scenarios, that's a term that you will see a little bit in this slideshow and in the rest that are to come. RCP being so for example, we had RCP 8.5, meaning that there was 8.5 watts per square meter warming at the end of the scenario. So that was a pretty big emission scenario. So there was a lot of warming. RCP 1.5, for example, and we had very little warming, 1.6. Now we have the SSP scenarios, which are more not only physically based, but also have a storyline approach to them, some different ways in which the world will develop and nations will work together, that have different types of scenarios associated with them. Again, I assume that others have explained this before in probably much more detail and much better than I will do right now, but just so you have an understanding, there's these different scenarios, right? So you cannot assume stationarity. In the next tutorial, we'll talk about how to incorporate that actually in the extreme value analysis. But here, what I want you to do is apply the techniques that we have seen before. So the ones where we split records and look at these different distributions over time and different parameters to see how how different scenarios affect the distribution of the climate. Here's a good example of that from a paper that recently came out. Here you see for different regions of the world that are used by the IPCC, how temperature and precipitation are changing over time in relation to their distribution. So you see the total change, but you also see separately how the mean is changing and how the variance is changing. This is, by the way, for the 99th percentile of the distribution, so the 100-year flood, you could say, or the 100-year event, you could say. And again, variance being, does this variable get more varied? So do we see more different types of precipitation or different types of temperature? The mean being, is overall the mean change? And you see that changes all around the world. So in some regions, the variance is the one that's changing most, and in some other places, it's the mean that's driving the change. Again, this is important when you think of climate as a distribution, rather than just a point of an average that's changing over time, like the 1.5 degrees or the 2 degrees global warming that we talk about mostly. Thinking about it as a distribution gives us much more, or much broader perspective, you could say. So here's an example of something you could do yourself, or things that you're going to do during your tutorial. We see here temperature, annual maximum temperature in Shanghai, under a low emission scenario, RCP 2.6, and a high emission scenario, RCP 8.5. And you see that there's quite a big difference, not only in just a shift in the distribution, so like a change in the location parameter, but actually in its variance, in the tail set it looks like. And understanding this is very important if we want to prepare ourselves or adapt to climate change. I can also show you the parameters from the GEV distribution from this. So you see that the location parameter changed. You see that the under RCP 8.5, temperatures, annual maximum temperatures become more spread. So there's also a chance of thicker tails and higher ends. And you see that the shape parameter is actually also getting different. So again, this is some of the exercises that you'll do. Good luck with that. I hope you enjoy it and see also the spatial components of where these distributions change differently around the world.